comes the fun part. Now we can take all this 2D information and solve the camera. And of course, as you might know by now, we're going to do this with the camera solver node. We're also going to estimate the lens distortion throughout this node. So let's see how to do that. As you know by now, to solve the camera, I have to go to the Solving tab, take the camera solver and just drop it into my tree view, and the focal length is being piped down from the estimate focal. The next thing would be to solve all. Okay, so it seems that all the trackers are green, and that's a good sign. I also can take a look at the error tabs and see that the residual numbers are extremely low. So my translation and rotation look good, and I could have taken those specific trackers and deactivate them here and either refine the scene or just solve it all over again. It's always a good practice to check if your pipeline is getting the proper results, and that would be by taking some of these nodes, duplicate them and repipe them and see if you get similar results. What I mean is that we can take the user track and duplicate it and pipe it down straight out of the footage itself without the estimate focal. I want to see if the camera solver itself will give us results that are closer to the results we got at the estimate focal. So I'm going to highlight my user track by double click on it, and I'm going to copy the selected node and then paste, and I'm going to pipe it down straight out of the footage. Thus, I'm bypassing all the work that I've done over here. So right after the user track, I can right click, go to my solving, select the camera solver. Again, the only thing I'm going to change is the medium smooth on the translation and rotation, and I want to see if the focal length, which is unknown at this point, is going to be similar to the focal length that we got through the estimate focal. So solve all. And the focal length we got here is actually 56 millimeter, and the arrows are very, very low. So we might even decide to go with the solution over here. The way that I work is that I test more than one solution if possible. But there is one thing we forgot to do in both workflows. We forgot to check the lens distortion. It is true that we could have taken the undistort node and insert it between the trackers and the camera solve, either here or here, but at the same time we could also go into the camera solver, go to the distortion tab and tell PFTrack to try to estimate it. So I'm going to resolve this pipeline, and now I got a low order estimated distortion of about 0.07, which is somewhat low, and you can see it at the edges of the frame. And I'm going to do the same thing here in this camera solution. Now it is most important that you use either the undistort if you detect any kind of distortion that occurs in the footage, and if you have a distortion grid that was filmed on set, it's even better. So here under the distortion tab, I'm going to click on estimate and solve all. So it seems that the distortion we got here is much lower than the distortion we got in here. And that's going to give us two different interesting results. We use the camera solver, of course, to solve the camera and the 3D space itself. We also use the error tab in order to trim some of the arrows and deactivate the troubled trackers. Next, we're going to orient the scene.